Hello students, today we'll start with the second chapter, parallel lines. What are parallel lines? When two lines lie in the same plane and do not intersect each other, lines are called parallel lines. Now, we have studied parallel lines 8th standard. Okay, so look at the board. Parallel lines. The lines which are coplanar. What do you mean by coplanar lines? Lines which lie in the same plane and do not intersect each other are called parallel lines. Here I have drawn one figure. This is plane H. In this plane, line L and line M are such that if I extend these lines, they do not intersect each other, and therefore line L is parallel to line M. In last year, in 8th standard, we have studied when two lines and their transversal intersect, the angles which are formed, we have studied different types of pairs of angles. Those are corresponding angles, interior angles, and alternate angles. Let us revise what we have studied in last year. Here, line L and line M are two lines. This line N intersect line L and line M into distinct point, and therefore this line M is called transversal of line L and line M. Here we get angles. This is A, this one is B, this is C, D, E, F, G and H. These angles formed by this transversal. The first type of angles are corresponding angles. So we get four pairs of corresponding angles. Angle A and angle E. This is angle A and this one is angle E. This is first pair of corresponding angle. Angle B, look at the board, angle B and angle F. This is second pair. Angle C and angle G, and the fourth one angle D and angle H. These are called pairs of corresponding angle. Then second type, interior alternate angles. Interior alternate angles. Angles which form Z shape, or this is a reverse Z shape. Look at the board. This is angle D and angle F. They form shape of Z. Therefore, the first one is angle D and angle F, and second pair is angle C and angle E. Third one, exterior alternate angle. What do you mean by exterior alternate angles? Angles formed by the opposite angles of this interior alternate. What are opposite interior angles or interior alternate angles? D and F. What are the opposite of those angles? Opposite of angle D is angle B, and opposite of angle F is angle H. So angle B, this angle, and angle H, they form exterior alternate angle, and the second pair is angle A and angle G. Angle G and angle A. Last type, interior angles. For interior angles, you have to remember C and this one. angle D and angle E. The first pair is angle D and angle E. The second pair is angle C and angle F. All these types of angles we have studied in 8th standard. These corresponding angles, alternate angles and interior angles are very useful in 9th standard and 10th standard. So revise this, remember this so that you will find it easy while studying geometry in 9th standard as well as 10th standard. Few more properties regarding angles we have studied in earlier standards. So we'll first revise what properties which we have studied earlier. Linear pair angles. When two adjacent angles, when non-common sides, they form pair of opposite rays. These angles are called linear pair angles. Here, angle AOB and angle BOC are such two adjacent angles where this side OA and OC, they form pair of opposite rays, and therefore these angles are called linear pair angles. What is the property of linear pair angles? Linear pair angles are supplementary. That is, measure angle AOB plus measure angle BOC is equal to 180 degree. What do you mean by supplementary angles? When their sum is 180, angles are called supplementary angles. Here, linear pair angles are supplementary. The sum of measures of linear pair angles is 180 degree. Now, vertically opposite angles. When two lines intersect each other, suppose here line PQ, line RS intersect each other at point O, this angle POR and angle QOS, the sides, the arms of these two angles, they form two pairs of opposite rays, and therefore these angles are called vertically opposite angles. And what is the property of vertically opposite angles? Vertically opposite angles are congruent. Proof of this theorem we have studied in earlier chapter. Angle POR congruent angle QOS, and the second one angle POS congruent angle QOR. So these properties will be helpful to us to study our next properties. We are going to study the geometry which is developed by Euclid. In his geometry, Euclid assumed some properties which are very obvious, or by itself they are true. Euclid assumed these properties are true, and these properties he called postulates. So what is Euclid's fifth postulate was, if line L and line M are given, line N is the transversal, and if this angle A and angle B, which are interior angles, if their sum is less than 180 degree, then if I extend this line L and line M, then line L and line M, they intersect each other. So what is Euclid's postulate? Line M is the transversal of line L and line M, and if angle A plus angle B less than 180 degree, then line L and line M intersect each other if they are extended towards this angle A and angle B side. We are going to use this postulate to prove next theorem. Interior angles theorem. If two lines are parallel, then pair of interior angles formed by their transversal are supplementary. Here in the figure it is given that line L is parallel to line M. Line N is the transversal. It means line L intersect line L and M into distinct points. Here the angles form angle A and angle B. This is one pair of interior angles. Angle C and angle D, second pair of interior angles given. How we identify given the part of the statement between if and then is called given part. Two lines are parallel. Here line L parallel line M and line N is the transversal. This is given part. To prove part, angle A and angle B, they form interior angles, pair of interior angles. They are supplementary. What do you mean by supplementary? Their sum is 180 degree. And angle C plus angle D is 180 degree. Here, angle A plus angle B is a number. And there are three possibilities for this number. Either angle A plus angle B is less than 180, or angle A plus angle B is greater than 180, or angle A plus angle B is equal to 180. What I am going to prove? I will prove that angle A plus angle B less than 180 is not possible. Again, angle A plus angle B greater than 180 degree also not possible, and therefore I will prove that angle A plus angle B is equal to 180 degree. So let us assume angle A plus angle B less than 180 is true. Then what will happen? By Euclids postulate, what is Euclid postulate? Euclid says, suppose these are two lines, this is transversal, and if pair of interior angles, the sum of pairs of interior angles, sum of measures of interior angles is less than 180, then if I extend those lines to that side, they intersect each other. So by Euclid's postulate, line L and line M intersect each other towards angle A and angle B. It means if I extend this line to this side and this side, line L and M are going to intersect. But what is given to us? Line L and line M are parallel, and we know that parallel lines cannot intersect each other, and therefore angle A plus angle B less than 180 degree is impossible. Understood? Now let us assume that angle A plus angle B is greater than 180. See what will happen if angle A plus angle B is greater than 180. I know that A and C, what type of angles are these? They are linear pair angles. Angle A plus angle C is 180 degree. Again, angle B plus angle D is 180 degree, as they are linear pair angles. Adding these two, what I will get? Angle A plus angle C plus angle B plus angle D is equal to 180 plus 180. How much it is? 360 degree. Now, what will be angle C plus angle D? This A plus B I will transfer to right hand side. So I will get angle C plus angle D is equal to 360 minus angle A plus angle B. But what is our assumption? That angle A plus angle B is greater than 180. If I am subtracting from 360 a number which is greater than 180, definitely I will get the number which is less than 180, and therefore I will get angle C plus angle D as less than 180. If angle C plus angle D is less than 180, so by Euclid's postulate, if I extend these lines, these two lines are going to intersect each other. Again, what we have proved? Parallel lines are intersecting, which is not possible, and therefore angle A plus angle B greater than 180 degree is impossible. So the first possibility, second possibility I proved not true. So obviously the third possibility, that is angle A plus angle B is equal to 180 degree, is the true one. angle A plus angle B is equal to 180 degree. Similarly, we can prove angle C plus angle D is equal to 180 degree. Thus, we have proved interior angles theorem. Alternate angles theorem. If two lines are parallel, then alternate angles formed by their transversal are congruent. Here I have given line A is parallel to line B and line C is the transversal. So given part is line A parallel line B, line C is the transversal. This is angle X, this one is angle Y. They form Z shape. It means they are alternate angles. What I have to prove? Alternate angles are congruent. It means I have to prove angle X is congruent to angle Y. So I will take one more angle over here. Let it be Z. What type of angles are these? Angle X and angle Z? They form linear pair. So proof. First statement, angle X plus angle Z, as they are linear pair angles, angle X plus angle Z is equal to 180 degree. What is the reason? Linear pair angles are supplementary. Now, this is line A parallel to line B and this one is the transversal. What type of these angles Y and Z? They form C shape. It means they are interior angles and we know that interior angles are supplementary. Line A parallel line B, line C is the transversal. This is given to me and therefore angle Y plus angle Z is equal to 180 degree. Reason, interior angles theorem, which we have proved earlier. C, statement number 1 and statement number 2. Right hand sides are equal, 180 degree, 180 degree. And therefore, left hand sides are equal, angle X plus angle Z is equal to angle Y plus angle Z. So, angle Z is common to both. Subtracting angle Z from both the sides, what I will get? Angle X is equal to angle Y. And therefore, angle X is congruent to angle Y. Hence, we have proved alternate angles theorem. What is that? If two lines are parallel, then alternate angles formed by their transversal are congruent. Corresponding angles theorem. If two lines are parallel, then corresponding angles formed by their transversal are congruent. Here in the figure, line P is parallel to line Q and line R is the transversal. So the given is line P parallel line Q, line R is the transversal. This is angle A and angle B. What type of angles are these? These are corresponding angles. So what I have to prove? Corresponding angles are congruent. Therefore, to prove is angle A is congruent to angle B. Now, I will take this angle C. Now, what type of angles are these? Angle A and angle C. They form linear pair. So, the proof, first statement, angle A plus angle C is 180 degree. Reason, linear pair angles are supplementary. Now, it is given that line P is parallel to line Q and line R is the transversal. B and C are interior angles. We know that if lines are parallel, interior angles are supplementary and therefore angle B plus angle C is 180 degree using the property interior angles theorem. So first statement, second statement, right hand side is 180 degree. Here also right hand side is 180 degree. Right hand sides are equal and therefore left hand sides are equal. And therefore angle A plus angle C is equal to angle B plus angle C from statement 1 and 2. Angle C is common to both sides. So cancelling angle C, that is subtracting angle C from both sides. What I will get? Angle A is equal to angle B. And therefore angle A is congruent to angle B. It means alternate angles are congruent. Hence proved. So thus we have proved alternate angles theorem. Practice set 2.1. Question number 1. Line RP is parallel to line MS and line DK is the transversal intersect these two lines in point H and point G respectively. Angle DHP, this angle is given 85 degree. I have to find out angle RHD, means this angle I have to find out. Angle PHG, this angle I have to find out. Then angle HGS, this angle I have to find out, and angle MGK, these angles I have to find out. Now first one, solution. This angle RHD and angle DHP, these two angles, they form linear pair, and we know that linear pair angles are supplementary. Therefore, angle RHD plus angle DHP is equal to 180 degree. Linear pair angles are supplementary. Substituting the value of angle DHP as 85 degree, angle RHD plus 85 degree is equal to 180 degree. And therefore, angle RHD is equal to 85. I will transfer to this side. I will get 180 degree minus 85 degree, and this is 95 degree. So, I will get RHD, angle RHD measure is 95 degree. Now, PHG, look at the figure. This angle and this angle, they are vertically opposite angle. This I am getting 95 degree. So, definitely this will be also 95 degree. Reason, angle PHG congruent angle RHD, reason vertically opposite angle. And from statement number 1, I will get RHD 95 degree. Therefore, PHG also 95 degree. Now, next one I have to find out this angle, which is that angle HGS. See, this angle and this angle, they are corresponding angles. When lines are parallel, corresponding angles are congruent. Line RP parallel line MS, line DK is the transversal, angle DHP is congruent to angle HGS. Reason, corresponding angles theorem. Since DHP, this angle is 85 degree, this angle will be also 85 degree. Now to find out last, MGK. This angle and this angle, they form vertically opposite angles. Therefore, angle HGS congruent angle MGK, reason vertically opposite angles are congruent, and therefore angle MGK is equal to also 85 degree. Question number 2. Line P is parallel to line Q. Line L and line M are their transversals. This angle is 110. This angle is 115. I have to find out angle A, angle B, angle C, and angle D. First one, what type of angles are these? Angle A and 110. Angle A and 110, they form linear pair. Therefore, first statement, angle A plus 110 is equal to 180 degree. Linear pair angles are supplementary. Angle A is 180 minus 110 degree, that is equal to 70 degree. Now, let this angle be E. What type of angles are these? Angle A and angle E, they form vertically opposite angles. So, angle A is congruent to angle E. Reason, vertically opposite angles are congruent. Angle A is 70 degree. Therefore, angle E is also 70 degree. Next one. Angle, so line P is parallel to line Q and line L is the transversal. So, this angle E and angle B are corresponding angles, and we know that if lines are parallel, corresponding angles are congruent. Therefore, third statement, line P parallel line Q, line L is the transversal, E and B are congruent, corresponding angles theorem, and therefore angle B is equal to 70 degree. Now, line P is parallel to line Q and line M is the transversal. C and 115, they are corresponding angles, and therefore angle C is 115 degree. Reason, corresponding angles theorem. Last one, angle D and 115 degree, they form linear pair. So angle D plus 115 degree is equal to 180 degree. Reason linear pair angles are supplementary. This 115 will become minus. So angle D is equal to 180 degree minus 115 degree, that is equal to 65 degree. Question number 3. Line L is parallel to line M. Line N is parallel to line P. This angle is 45 degree. How to find out angle A, angle B and angle C? First, I will take this angle. Let this angle be D. Angle D and 45, they are vertically opposite angles, and therefore my first statement, angle D is 45 degree, vertically opposite angles are congruent. Now, line L is parallel to line M and line P is the transversal. So what type of angles are these? Angle A and angle D. These are the interior angles. Angle A plus angle D is equal to 180 degree. Interior angles are supplementary, that is called interior angles theorem. Angle A plus angle D, we got 45 degree is equal to 180 degree. I will transfer this plus 45, it will become minus 45. Angle A is equal to 180 minus 45 degree, that is 135 degree. Now, angle A and angle B, they are vertically opposite angles, and we know that vertically opposite angles are congruent. Therefore, angle B is 135 degree. And finally, this line N is parallel to line P and line M is the transversal. So, angle B and angle C, they are corresponding angles. So, angle B is congruent to angle C, corresponding angles theorem. And we know that angle B is 135 degree from statement 3, and therefore angle C is also 135 degree. Question number 4. Sides of angle PQR and angle XYZ are parallel to each other. It means this PQ is parallel to XY and QR is parallel to YZ. What I have to prove? Angle PQR is congruent to angle XYZ. This angle I have to prove congruent to this angle. So I will construct something. Draw line XY. This I will extend this line. I will draw line XY. This line intersect side QR at point P. Now look at the board. This is side PQ which is parallel to line XY, and this QR is the transversal. So this angle is congruent to this angle. This is angle, first angle is congruent to second angle. Angle PQR is congruent to angle YTR, corresponding angles theorem. Construction, draw line XY, it intersects side QR at point P. Side PQ, this is parallel to this, and QR is the transversal. So angle PQR is congruent to angle YTR, reason corresponding angles theorem. Now I will consider this line QR. This is side QR, this is side YZ, they are parallel, and this one is the transversal. Then what type of angles are this? This is angle number 2 and this is angle number 3. That is YTR and XYZ, they are corresponding angles. Therefore, angle YTR is congruent to angle XYZ, reason corresponding angles theorem. From first statement, first angle is congruent to second angle and second angle is congruent to third angle. So, from statement number 1 and 2, first angle is congruent to third angle, that is angle PQR is congruent to angle XYZ, reason from statement number 1, 2 and transitivity. What is transitivity? When the first angle is congruent to second angle and second angle is congruent to third angle, then the first angle is congruent to third angle. This is called transitivity. Hence, we have proved angle PQR is congruent to angle XYZ. Question number 5. Line AB is parallel to line CD and line PQ is the transversal, intersect these two lines in point R and T respectively. Angle BRT is 105. What I have to find out? Angle ART. Where is angle ART? ART. Angle CTQ. Angle CTQ. Then angle DTQ and angle PRD. First one I will find out angle ART. Look at the board. This is angle ART and this is angle BRT. They form linear pair. This angle is given to me. So the first one, angle ART plus angle BRT is equal to 180 degree. Linear pair angles. Angle ART plus substituting angle BRT as 105 is equal to 180 degree. If I transfer this 105 to this side, angle ART is equal to 180 degree minus 105 degree, that is equal to 75 degree. Now I have to find out CTQ. Say this angle I got 75 degree and this I have to find out what type of angles are these. If this is parallel to this one is transversal, this angle ART and angle CTQ, they are corresponding angles. Line AB parallel line CD, line PQ is the transversal, angle ART is congruent to angle CTQ, corresponding angles theorem. ART from statement number 1 is 75 degree, therefore CTQ is also 75 degree. Now I have to find out DTQ. Say this angle BRT is known to me. If this is parallel to this one is transversal, this angle BRT and angle DTQ, they are corresponding angles. AB parallel to CD, PQ is the transversal, angle DTQ is congruent to angle BRT, corresponding angles S. But angle BRT is 105, therefore angle DTQ is also 105 degree. Last one I have to find out PRB. This angle PRB and this angle ART, they are vertically opposite angle. Therefore angle ART is congruent to angle PRB, vertically opposite angles, and therefore angle PRB is also 75 degree. Today we have learned interior angles theorem, corresponding angle theorem, alternate angles theorem, and practice set 2.1. So solve all these theorems and practice set well.